All right, I'm gonna check out the chat in just a second, everyone. All right, let's see what we have here. So I see some stuff in the chat. We have, let's see. Does the silent laugh count? Is that the one where you're out of air? The out of air one? And it hurts? um, if it is, then yes. I hate my laugh, but it's a natural laugh. That's good. We have out of air laugh. I don't like my laugh either. It's not cute. I have more than 10 laughs. Me too. I think I do all of those that are right there on the list. I do all of them. Scream laugh or out of air. Yeah. Especially when I'm with my sisters, like if we see something really funny, we start yelling and screaming while laughing. It's crazy. Yeah, the one where you make no you make no sound and you're gasping for air. Okay. Okay, no problem, no problem. Thank you for letting me know. All right, we have the scream laugh and the silent laugh, quiet laugh, scream laugh, and sometimes snort. We have our all. When it's out of control laugh, it's amazing. This week is the Office's week because it was released on March 24th of 2005. I had no idea about that, to be honest, Francisco. I wonder if you started watching it and if you think it's good. I don't know. Not everyone has watched The Office. I love this GIF right here. Yeah. So yeah, I definitely do all the laughs, but if it was to me, my favorite laugh would either be the yelling one or the out of air, but the out of air one hurts. Like it's so funny that you're out of air, but it just hurts. Like it's so painful. But yeah. All right, y'all. Thank you so much for sharing your favorite method of laughing. It makes me laugh because now I'm thinking about funny stuff. Okay. Let's see who we have absent, and y'all can correct me if I'm wrong. I am missing Ariana. I'm missing Tyreek, Dennis, Jorge, Miles. Am I missing Kayla? Am I missing you? Hold on a sec. Kayla. Yeah, I'm missing Kayla. Alicia, are you here, Alicia?
Yes.
Okay, you're here. My bad. You're here. August. I'm missing August, Marco, and that's it. So let me just double check everyone. Let me just do another rundown so I can make sure that I did this correctly. All right, so this is what I'm missing formally now. Ariana, Tyree, Dennis, Jorge, Miles, Kayla, August, Marco, and that's it. So that is who I'm. Oh, Kayla's coming in. And if you're friends with anyone else that I just mentioned, if you could please send them a text to come on into class. We will have some credit today, some in-class credit. So let's get some of that credit. Just hit submit. All right. So what's on our agenda today? Our agenda. We just took attendance with that checking question. What I'm going to do is I'm going to recap the stuff we talked about last week. And then we actually have a Google form. So that's going to be one of the major forms of our participation today. It's going to be a check-in on like how you understand the big ideas and its application. We're going to talk about what about cosine? Because we looked at sine graph, but what about cosine graph? We'll see if we actually do number 4, right? This all depends on timing. If we don't get to it, we don't. Asynchronous number 11 is actually due tonight at midnight, everyone. The hope is we do get to do a similarities and differences activity, but if we don't get to it, that's okay. And then we'll have a checkout. As a reminder, asynchronous number 11 will be due tonight. Does anyone have any questions of anything or about the asynchronous stuff? Oh, great question. On my office hours today. Not today, but tomorrow at 2 and Wednesday at 2. So Tuesday, Wednesday to 2. I also do have small group if anyone's interested. I had some today though. I had some today at 10. If anyone like wants to pop in at 10, that's also okay. Um, and I have another small group on Wednesday. So let me know. All right, y'all. Oh, is the final due before spring break? No, but you will have access to the mini final. Like you'll have access to it, so you could also look at it and or turn in a draft if you desire before spring break. But the mini final is not gonna be due before. It's gonna be due definitely after. Once we come back from spring break. All right, welcome to those that just came in. I was just going over the agenda. We're answering some questions. Let me know if there's any other burning questions. Those were great. All right, awesome. Let's go ahead and jump into our recap and then we'll have a Google form. Make sure you do that Google form there so that you could get some credit. So this is our recap. So last week we talked about how in the world does a unit circle give us a function that has waves? That's what we're investigating. And there was an essential question right there. How in the world unit circle connected to functions with waves? And you all did like a teeny little mini group thing where you kind of investigated this here question. Like, how do you get waves from this? Specifically, what we're looking at is how does a unit circle give you a sine wave. So actually what we were investigating was a sine wave specifically. We didn't really take a look at cosine yet. So let me clear that. All right. Okay. And by the way, as a reminder, make sure that you're following along with me on our slides. They are on Google Classroom. We are on day 7, and I am right now on slide 6, and I am recapping with you all. So what we also learned was that a sine wave is basically formed by imagining a point in the circumference of your circle. So it's on your circumference, and you're tracing its height. And I've specifically put vertical height now of that point over time. And what helped kind of understand this is imagining you boarding a Ferris wheel. You're boarding it and you're going to go up. So you're rider boarding, then you over time you're there. And over time, you're of course going to go up and down on this Ferris wheel. And what we're monitoring or kind of measuring is your height over time. This height gives you your wave nature that we're talking about. And this specifically is actually a sine wave. So you start at 0 feet. So imagine you're boarding and you're on the ground. You start at 0, and then you're going to go up to a maximum, which correlates to this peak right here. Then you're going to go back down to 0 where you boarded, and that's down here. So see, after 3 minutes, you made 1 loop, and then you keep going, right? So this looks like you made about 3 loops. So you keep going up and then down, up and down. So basically how we get a wave from a circle is by tracing the height of a point on a circumference over time. You imagine that that point is moving kind of like a rider on a Ferris wheel. So that is what we got from last week. And again, pause me for any questions or any clarifications on these big ideas. Nextly, this is actually where we left off and we did not really get to talk too deeply about, but these functions that model wave-like behavior, they're actually called sinusoidal functions. It sounds so weird. I just call them trig functions, but go ahead and call them sinusoidal if you want to be technical. Sinusoidal functions are basically your sine or cosine. Notice how sine looks just like cosine, but it looks like that cosine is kind of shifted. It's shifted over to the left that way, and it looks like it's shifted over by pi over 2, or basically by 90 degrees to the left. It's shifted that way. So that's what cosine and sine look like, and both of these represent any wave-like behavior. And also take a look, your input can be in radians, or it could also be in degrees. I'll let you know in calculus and higher level math, they prefer that the input be in radians. So you are more likely to see this x-axis labeled with radian measure instead of degree. So there's that. So there's a little bit of background and things you should know. I'm going to go ahead and transition us now into slide 8. So slide 8, you might want to take a little bit of annotation on. Slide 8. Oh wait, no, not this one. It's the next one. Slide 8. So on your Desmos, some groups to the last part where you were asked about what was the same or different about the certain graphs that look like this. There's like two more graphs. But what these are called periodic functions. The term is right up here. Periodic functions. Now, what are those? There are functions that create a repetition of values at regular intervals. And a period is the length of one of those intervals. So, what we're studying right now, waves and things like that, it is a form of a periodic function. So, basically, like for example, this one here, we can imagine it starts here and ends here. Let's imagine that. And it's going to continue to repeat this pattern. So that's the repetition of values. And then at regular intervals basically means over a certain x value amount, it's going to repeat over a certain domain amount. So domain is your x input. So this right here looks like a sine or a cosine wave, but if you look at this thing, this looks a little bit funny. This doesn't look like a smooth sine or cosine wave. There are waves in this, but it looks like weird, like almost box-like, or kind of looks like a ghost head or something. That's kind of how I'm looking at this. But notice, let me go ahead and draw on this. Notice if I just draw like vertical lines to kind of chop up the domain, my x values, like so, you notice that these locations are where the y values are repeating. So this looks like the repetition happens at every 2 pi. Because I see 0 to 2 pi right here. So every 2 pi, it looks like this kind of hump stuff gets repeated over and over. So whenever you have that repetition at regular intervals, that is called a periodic function. And we're going to study period and what that means as well today. Let me just pause to see if there's questions or anything like that on slide number 8. If not, we'll transition to slide 9. All right, all right, cool. Like I said, I don't really like talking a lot, but it's like I have to cover these portions. I want to get to the part where you all get some work in or discuss, but let's see. Okay, y'all. So what in the world is a periodic function? Like how do textbooks define this? So a periodic function has to have something called a period. We call it P. As you can see up there, it's called P. And basically a function is periodic if it has this property. If it has this property. If it has x, f of x plus p is equal to f of x. So basically your input after a certain amount of time is going to give you the same y value, which is basically the patterns that we're seeing when it comes to waves. So this is true for all values of x and x plus p in the function's domain. Remember, domain means x. And then again, feel free to use comment and annotate on this slide to kind of just remind you of these little definitions. So this is like the formal way to define a function that's periodic. Like you could also define it yourself by saying, well, I see that it's repeating, like a wave is repeating over time, every certain amount of time. Or you could visually determine when a function is periodic. So this right here in this example, we're looking at a sine wave. So the sine wave basically has a period of 2 pi. The period is 2 pi because it starts at 0 and then it ends at 2 pi. That's one rotation or one, you know, one cycle is kind of how we say this. And after this 2 pi, the cycle repeats, or even before the 2 pi, the cycle is repeating in the opposite directions. So the period here is 2 pi. How in the world would I use this textbook definition to kind of convey that? How we would do that is this. So if we know that a function is periodic, if it has this property, we just determined that the period right now was 2 pi. So then p becomes 2 pi. So this is periodic because this is true. That's how you would use that definition. Period length is 2 pi. Basically, after every 2 pi, right, you're going to get repeated y values. That's what this is saying. So let me write that down here. After every 2 pi, I'm going to use the shortcut to write pi that Francisco taught. So 2 pi, there we go, option P. After every 2 pi, your cycle repeats. That's what this is saying right here. That's just the interpretation of this symbolism right here. Let's see, does anyone have questions on this part right here? And if not, let's jump into the application and examples, and then we'll have our Google form. Okay, and feel free to still, develop and or ask questions if any comes up. If not, let me clear this up and let's jump into some practice or how to apply this. And what our practice is going to focus on for today is how to determine period, how to determine what is the length of a period. So right here, we were told that the period length is 2 pi, just with these kind of colorings and annotations. But what if it gets confusing and you see so many waves and you can't tell where it starts and ends, right? How do we know? There's going to be a specific rule. And how I'm going to help you all kind of see that is we're going to return to the Ferris wheel once again. I am on slide 10. There is a 6 here because I took a screenshot, but this is slide number 10 right now, everyone. Let us find the period of this Ferris wheel. So it's the same one that we looked at from before. How do we find the period? One way is you could imagine it the way I did, where I'm like, okay, I start here. So I start at 0 feet. And then I know that I have to go up, up, up and hit a maximum. That's right here. And then I know that I have to come back down and return to my initial height. So that's maximum and going back down to your initial height. So according to this, one cycle ends after about 3 minutes. And that's how I looked at it. I looked at the visual and made a connection with the graph. But there's another way. Another way is probably the way that I'll continue to use, because you're going to see different kinds of waves and you're not going to know where it starts, right? Like, is it going to start at the top? What if there's a Ferris wheel where some Ferris wheels you board at the top, some of them, or some of them you board it right in the middle. So how do I know where to start and where I end? How do I determine the period, the length of one cycle? Here's the other way. So let me share with you the tech. Let me just click here. Here's the technique, everyone, the strategy. Another way to determine the period is you count the distance between two maxima. Maxima are basically two maximum points or two peaks. Let me also put that here. Or two peaks. Between two peaks. Oh my gosh. Or between two peaks. There we go. So let me show you. I'm going to use these measuring tools right here. Oh, actually, no, I don't. I know it's on my slide. There we go. So right now what I did is I drew a straight line, kind of like I'm measuring with a ruler. Let's imagine that red line is a ruler, and I'm going to measure that distance between these two maximum points, or you could say between these two peaks. Now, how do I know what the length of that red line is? What you could do is you can use your x-axis as a ruler, kind of. So what I'm going to do next is I'm going to take this red line and I'm going to put it down here. How you would do this in person though is with maybe with your fingers. Like you just measure with your fingers and just go down to your x-axis and measure like up to where is it at. So this is what that looks like. Pay attention to my x-axis here. See that? You see the red line just appeared right there. So I took that, I dropped it here to kind of see what the length is. As you can see, it agrees with what I saw visually, that I bored the ride at the bottom. One cycle takes about 3 minutes, and that's exactly how much the measurement between two maximum points or two peaks was. So that is the way we're going to find the period of any wave or any sine or cosine function. Does anyone have questions about this strategy? And again, the strategy is right here as well. So this is kind of like a shortcut strategy. If, what if you don't even have a visual, or what if you don't know where exactly you're starting and where you're ending? Again, the strategy is you measure distance between two peaks. And then what I like to do is I'd like to go down to the x-axis and kind of just transfer that exact length to determine exactly what that is. And in this case, the period for this Ferris wheel is 3 minutes. The length of one cycle. Oh my goodness. Okay, cycle. There we go. So there's a little bit of, maybe if you're annotating your slide, if you want to add that in, and or anything additional to kind of help you out here when you're using this strategy. Let me pause for questions, and then we'll jump into two very quick examples, and then it's going to be the Google form. Okay, so I have a question there in the chat. Can we do 6 through 3? So let me see. Let me go back on So delete my lines. So according to the definition, it's usually when you measure between maximums or minimums where you could get your period. So if we did 3 to 6 or 6 to 3, that works because these are both minimums. So someone was saying, can we do between 3 and 6? So let me just do that. See, 3 to 6 is right here. You can also do it between two minimums. I don't know if you would call these peaks though. I don't know what you all would call these instead, but this works too. So this, as you can see, would be 6 minus 3. The length of this will still be 3 minutes. So yes, that works. You can do between 6 and 3. So you could do between two minimums or two maximums. That's a great question. Cool. Any other questions on this one? All right, awesome. And then questions might come up because we're about to do some more examples. Except in these upcoming examples, we're not going to have a Ferris wheel. You're just going to be like, it's an actual skill application now where you actually just look at a graph and try to apply like, okay, what's the period? So let's go ahead and jump into that. So this is slide 10. Let's move on to slide 11. Let's do this. Oh, my bad. The last thing right here, by the way, if you want to apply the period definition, in this case, remember the period length was 3 minutes. This right here is just kind of defining the fact that this Ferris wheel graph is indeed periodic, according to that previous slide's definition. Again, let me know if anyone has questions on this. If not, let's jump into some practice. Okay, let's do this. Let us find the period of this thing. So first off, let me say this is a sine function. Let's find the period of this. So some of you can perhaps look at this and be like, okay, I know when a cycle ends and starts. Some of you, perhaps it's difficult. And sometimes it gets difficult for me. Sometimes the waves get all jumbled up and I can't tell where it starts or ends. So I like to use that technique or strategy where I'm gonna draw a line between two maximum, or you could do minimum, and just look at the length of that. So let me do that. I'm gonna choose these two right here. So I'm gonna find, there we go. See that red line? I just drew it between two maximums. Now, I don't know what that length is because our scaling could be different. We're gonna use right here, see our x-axis? We're gonna use our x-axis as though it's a ruler, and it's gonna tell us how long this length is. So I'm gonna take this and drop it down on my x-axis. Y'all see that? So what length is that red line that I just drew? Let's see if anyone in the chat or if you can unmute can tell me what is the length. Yes, we got 4 pies there by Francisco and Leslie. I 100% agree. It is indeed 4 pi. That is the period. That's our answer. Let me know if anyone has questions on that. 4 pi is our period. And then we got one more example just like this, and then we'll be ready to jump into that Google form to check our understanding. Again, it's going to be like a process check. Like, what do you understand so far? And then, I encourage you to have your slides open when you're doing your Google form, just so you don't forget certain things. Oh, by the way, it's participation all the way. So if you get stuff wrong, that's not any, you will get an A as long as you do the form. So no problem. Don't worry about that. You'll get your full credit. It's all about your learnings. Okay, let's look at this funky one. So it's still a wave, and let's go ahead and find the period of this. You could choose any two maximums or any two minimums. I'm gonna just focus again once more here. So I'm gonna choose these two. I'm gonna measure it with a line. I'm gonna take that, put it on my x-axis, and the length of that, it looks a little bit past it, but it's actually gonna be, let's see. We have 2.5 pi. I don't know if I measured this wrong. So Francisco, so see how my thing is a little bit off? Let me see. Let me redo it. Like, you would be right, but I think the answer to this, and that's because
Is it 3 pi? I feel like.
okay, so you're saying it looks like 3 pi. Let's see. Let me redo my line. Let me do this. I'm gonna do this right. Okay, from here to here. And then, oh, here's another way, guys. Look, this has 1, 2, 3, 4. You see there's 4 boxes between here? I could just count 4 boxes. That's another way to do it. So see, this is 1 box, 2 box, 3 box, 4. Feel like I'm singing a song. So then we have 1 box, 2 box, 3, 4. It looks like it ends at here. And that was my fault. So the original line I drew was a little bit past the true length. So that was my bad. So yes, the answer is actually 2 pi. And I kind of use these boxes to kind of help me count the length of this line. And then I went back to the x-axis to use that as a ruler, and I counted 1, 2, 3, 4 boxes. That ended up at 2 pi, everybody. Let's see, does anyone have clarifying questions on that one? So this one, the length of one period is 2 pi. That means for this wave, it repeats every 2 pi. It just keeps repeating its wave every 2 pi. So it looks a little bit scrunched up. Period for this one is 2 pi. Again, I drew that original line too big or too long, so that was my bad. Oh, that's a good question. So here's a question from the chat. X-axis still our time, right? And Y is height. So actually for this one, so for example, Francisco, sometimes waves can even represent things like sound. Sound could be the input as time, but sometimes people even use sine or waves for like the moon. Like, how the moon kind of has its different moon phases? Sometimes it's time. So usually X is time. Yes. Sometimes it's not though. And I'm trying to think of an example. Yeah, sometimes it's not, but if it helps you, you can think about your X as over time, usually. Y sometimes could be height or it could be something else. It could be like the amplitude of your sound or something like that. It would definitely represent height though if it's a Ferris wheel. So it has super like so many applications. So sometimes it represents height, sometimes it doesn't. But you could think of it like that, like a Ferris wheel with height and X being. That's a great question. All right. Any last burning questions before we jump into that Google form so we could get some practice on this and kind of like just general practice on, not practice, my bad. So we could check in, like your process checking how you feel about all of this so far up to this point. That's what it's going to be, a little process check. And it's okay if right now our understanding is a little sloppy. That's no problem. We'll have time to like, tidy that up. Okay, everyone. If you're ready, we're gonna go ahead and jump into the Google form. This is on slide number 13, and this is a process check. That means it's mostly like for me to know where everyone's at and for you to also know, like, uh-oh, I need help on this. And then maybe come on in, to office hours or something. It's okay. You could try it, August. And then like if it's hard, that's good for information for you to know and for me to know. That way, you could come on in and we could find out like where and how to support you all. So again, I put two different ways people could be taking this, like, oh boy, I'm stuck, or yeah, I got this. Wherever you are, or you might be in between, it is legit. So don't worry about it. Let's just see how we're doing so far. And let me open this with you. In a second, I'll start our timer. You're going to be inputting your email address. Then for number one, I'd like to know what's your understanding about when I described these waves, like kind of like a rider boarding a Ferris wheel. Like, what did you understand in your own words? How can this help us model a wave? Next question is, how do you know when a function is periodic? You could use the visual below, or you could also put your own understanding. Periodic is defined on this slide, or you could also look back at additional, back to today's slides to see what else I said about that. I have, is this function periodic? Why or why not? And number four, the last question, I'd like you to find the period of this function here. And that would be the last. So there are four questions. Some of them are kind of prodding you to think about these big ideas up here, Ferris wheel connection, and also about a function's period and what makes a function periodic with the visual below. Does anyone have any questions about this Google form before we start our 8-minute timer here? All right. If you do have questions, feel free to just use the chat. I'll be right here. I want to definitely give you all your protected time to go ahead and, let me know where you're at here as far as your understanding is concerned. As long as you do this, fill it out to the best of your ability, you will get 100% credit. It's definitely just a process check. All right. Let's go ahead and begin. I'll be here for any questions. Just use the chat. Let us be back in about 8 minutes, everyone. Hey everybody, so the 8-minute timer is up, but I'm gonna actually give like 2 more minutes because I still see a few of us still working on this Google form. So let's check back in 2 minutes. And yes, I will also go over that last problem where it asks you what's the period. So be prepared. I will go over that because I'm seeing different answers. So definitely let's check in 2 minutes. Let's get this in. All right, everybody, welcome back from that Google form. Let me just go ahead and open it. Oops, I already had it open. So here's the thing. I want to make sure I'm not showing names or anything. Give me a sec. I know a few of you still have to submit this, so let me just scroll away so I could, there we go. There we go, perfect. I kind of just quickly scrolled down to make sure I make this anonymous. Again, if you're still working on it, please just submit it. I definitely wanted to talk about number 4. Why? Because I'm noticing there's a variety of answers. We have that the period of that last graph was 1.5 pi. We have that it's around 2 pi. We have some confusions and some questions. We have where it starts and ends and so forth. So there's different things, right? Different things coming up. Some of you are using that squares method. Some of you are using the strategy of counting between the maximums. So the maxima, this student got 10 pi. There's another question that is like half a wave of period. And then I see something from 0 to 2 pi. So there is definitely something that we need to come back to. So let's talk about this one. Let's go over this together. So let me go back to the questions and pop this up. So this is the one that I asked you all to find the period of. Here's the strategy. Let me just type it out. So the strategy, as a reminder, is to measure the distance between two maxima. Someone else did it between two minima. That's fine. Minima means two minimums. Between two maxima. Maxima are basically your peaks. Between two peaks on your graph. Peaks are like two high points. So immediately I look at my picture and let me draw where I see two peaks at. I see a peak right here. It's a high point or a maximum. And I see a peak right here. I need to measure what's the distance between those two. One way to do it is I could imagine that I kind of have like a ruler and I'm going to just measure this distance. Like, okay, it's this length. And I really wish I can, like with the tool that I'm using right now, I can't really copy and paste, right? So what I'm gonna do instead, like, okay, I can't copy and paste. What I'm gonna do is I'm gonna count the squares. I'm gonna count how many squares are there between this peak and this peak. And then after I count the amount of squares, I'm going to go down to my x-axis and try to count, well, what does that amount of squares represent? So let's first count the squares. Correct me if I'm wrong, everyone. So I'm going to count the squares between this maxima and this maximum. Okay, so I have one. You just put a dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 once I hit this point. So we have counted 12 boxes between these two maximum points. Hopefully we agree. Did y'all see me count that? Make sure you got 12 boxes. Let's see what's in the chat. Okay, we have an agreement. Okay, good. Like I said, sometimes I mess up on counting too, so I wouldn't be surprised if I got called out on that. Okay, next step. Let me write it down. Next, after we count the amount of boxes, we go down to the x-axis and use it as a ruler. A ruler. So let's do that. So I'm going to go down to the x-axis because the x-axis has actual length marks on it. It has pi right here, 2 pi, and then right here it's 3 pi. So let's count 12 boxes down here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this last box ends exactly where 3 pi is at. So the length of 12 boxes is the length of 3 pi. Y'all see how I did that? Let me know if there's any questions, but the period therefore of this function is 3 pi. That means these waves are repeating every 3 pi on your domain. So the answer to this question is the period is 3 pi. And I use that x-axis as a ruler to see where 12 boxes ended up at. So that is the answer for this one, 3 pi. Let's see, are there questions though? Let me wait for some questions. And as questions are developing, if they're coming up, as they're developing and as they're coming up, sorry, I had a little pause in my brain, but I wanted to say that this is another reason why I did this process check, because then I'm able to see where we're getting stuck at and what we need additional like support with. So that's why I'm happy, because otherwise I would have moved on from period and just been like, okay, let's talk about this and that. So I'm actually glad that we did this check right now so we could kind of catch that. But of course, please, if you have any more questions on how to do this, or what I just did here in this problem, let us know. We will be trying to figure out periods when it comes to our mini final. So it's super important. I see more of you are turning this in. Awesome. Make sure that you turn this in for your credit here today. I'm going to go ahead and jump us into our checkout. So no, we didn't really get to do everything on our agenda today, but that doesn't matter because I think it's important that we deeply understand this right here. So let me go ahead and take us into our checkout, everyone. And I think the checkout is going to probably be changed. Let me go down. I think I kind of over planned today. Okay, so take that. Let's talk about what was confusing. Let's do that as our checkout here today. What was confusing? And I have my little annotations here. Let's go ahead and think about that. What was confusing here today? It could have been something that you found confusing and now you understand, or it could be something that you're literally still confused about and perhaps you want to jump into office hours for. Let's go ahead and put that in the chat. Sorry, I have warrior bunnies. They moved over into the kitchen. Yeah, they're not with me at the moment, but they're probably sleeping. All right, we have things that were confusing. How the Ferris wheel is connected to the waves. Finding the period, a little bit confusing. Today I was actually able to understand how to find the period. Okay, okay. And we got what Aisha said. So making the real world connection to a model, that is hard. I agree with you. That could totally be confusing. Then we got finding the period. Yeah, because we definitely all had a different idea of what the period was for that last one. Measuring the ways. I was confused about counting the period, but now I think I understand it. Okay, that's awesome. Yes. We have, yeah, that period. And then confused about the period at which squares I should count. I thought it was the ones between the lines across the y-axis, but now I know it's between two maximums. Yes, I'm happy that you said this, so that it kind of like stays in with everyone else. Like, oh, we're counting between two maximums. That's going to be the length of a period. That's going to be the shortcut way to determine that. All right. Anything else that might have been confusing here today for anyone else? Again, I like this question because when it comes to math, confusion will happen. That's going to be part of the learning process for sure. So celebrate that you were confused because that means you were trying to understand it. So that's awesome. I was confused about how to measure in the start, but now it makes more sense. Yay, I'm glad. I'm glad for that. And I kind of forgot what a period was. I don't know. So I don't know if it's still forgotten yet, but if it is, just so you know, tomorrow office hours at 2. Also Wednesday at 2. As a reminder, everyone, before some of you are heading out already, but tonight we do have asynchronous number 11. Try your best on that. So just try your best. Don't worry so much about being 100% accurate on it. But jump into my office hours if y'all have questions. All right, everyone. Enjoy your lunch. Bye, y'all. Bye.
Sedano.
Bye, everyone. See ya.